Hello everyone, my name is Madhav Gupta. I am currently pursuing BTech in Computer Science from Benet University. In this video, I will discuss about Moore and Mealy machines, and I will also discuss about how to convert an Moore machine into Mealy machine and Mealy machine into Moore machine. So let us start our discussion by understanding what is Moore machine and Mealy machine. Moore machine is an FSM that is finite state machine whose outputs depend on only the present state. As we earlier know, DFA and NFA automatas are only used to check whether the machine accepts the string or not. But this Moore machine is a finite state machine which also has output. A Moore machine can be described by a six tuple that are Q, sigma, O, that stands for output, delta, X, Q naught, where Q is a finite set of states, sigma is a finite set of symbols called the input alphabet, O is a finite set of symbols called the output alphabet, delta is the input transition function where delta is Q multiplied by sigma that gives us Q itself. Q naught is the initial state from where any input is processed. Q naught belongs to Q. De sorry, Lambda is the output transition function where lambda is Q goes to O. Lambda is the output transition function where lambda is Q goes to O. So let us understand these six tuples with the help of an example. In this example, our machine starts from here. This arrow signifies that our machine starts from here. Q naught, that is the initial state. That Q naught slash 0 denotes that Q naught state has an output of 0. Now let us consider the tuples. The first tuple, that is Q. Q is the Q denotes all the finite states in our machine. In this example, we have Q0, Q1, Q2, Q3, and Q4 as the finite states. Sigma. Sigma is the input symbols that we give to the machine, that are 0 and 1. Output. O denotes the output symbols. Outputs are only denoted by 0 and 1 by the machine. Delta. Delta denotes the transition function from Q to sigma. Q multiplied by sigma, that itself gives us the Q, that are Q0, Q1, Q2, Q3, Q4. Q0 denotes the initial state in our machine. This is the Q0. As we know that our machine starts from here because this arrow does not have any input symbol. That means our machine starts from here. Lambda. Lambda is the transition function of output. Uh, this signifies um, what is the output at a particular state. We can see on Q node the output is 0, on Q1 the output is 0, on Q2 the output is 0, on Q3 and Q4 the output is 1. Now let us understand what is Mealy machine. A Mealy machine is an FSM that is finite state machine whose output depends on the present state as well as the present input, as compared to the Moore machine in which the output was only dependent on the present state. The Mealy machine can be described by a six tuple that is Q sigma O, that is output tuple, delta, X and Q naught, where Q is a finite set of states. It is same as the Moore machine. Sigma is a finite set of symbols called the input alphabet. O is a finite set of symbols called the output alphabet. Delta is the input transition function where delta, that is Q multiplied by sigma, gives us Q itself. Q naught is the initial state from where any input is processed, where Q naught belongs to Q. Lambda is the output transition function where lambda is Q multiplied by sigma, that gives us O. So this is an example of a Mealy machine. We will look further about the six tuples for this example too in the next slide. But firstly, we should understand how this Mealy machine is different from the Moore machine. As you should have noticed that there is no output given for a particular state. Instead, there is a output given for an input from a given state. Let us understand what does it mean. Let us consider the Q2 state. From this Q2 state, if we give input of 0, that is, it goes to Q1 state, we get an output of 1. But from Q2, if we give input of 1, we goes to Q2 itself and we get an output of 0. But in Moore machine, we had only one output at a particular state, not other outputs. So let's see different tuples for this example. The first tuple is Q, that is the finite number of states that are Q0, Q1, Q2. The next tuple is sigma. Sigma represents the input values for the machine. In this example, 0 and 1 are the only input values given to the machine, and O represents the output values that are also 0 and 1. Delta represents the transition function from Q multiplied by sigma that gives us Q itself, that is Q naught, Q1, Q2, and Q naught is the final, Q naught is the initial state of the machine, that is Q naught, and the initial state can be identified by the arrow which does not have any input or output value noted above the arrow. Then last tuple is lambda. Lambda represents the output transition function. Uh, in this case of Mealy machine, the transition output transition function also depends on the input given on a particular state. That is, let us see for the Q naught example. The Q naught, when Q naught is given an input of 0, we get an output of 0 and we go to the state Q1. And when we give input of 1 on Q naught, we get an output of 0 and the state we get is Q2. Now, let us summarize some of the key differences between Mealy machine and Moore machine. Mealy machine output depends both upon the present state and the present input, as we have seen in the previous slide. Moore machine output depends only upon the present state. Generally, it has fewer states than Moore machine. Generally, it has more states than Mealy machine. Actually, this is because of uh, the initial input value that we take. In the Moore machine, we have a initial input value that we have to keep. That gives us the one more extra output. But in this, it is input values are equals to the output values. The value of the output function is a function of the transitions and the changes when the input logic on the present state is done. The value of the output function is a function of the current state and the changes at the clock edges whenever state changes occur. Mealy machines react faster to inputs. They generally react in the same clock cycle. In Moore machines, more logic is required to decode the outputs, resulting in more circuit delays. They generally react one clock cycle later. Now we will see some problems on Moore to Mealy machine conversions. Now given is the Moore machine, we have to convert this machine to Mealy machine. Now the first step is to identify the given states that are Q0 and Q1, and we will see the input strings input values are A and B, and the output is given by 0 and 1. So first of all, we can see that at Q1 state the output is 0, and at Q1 state the output is 1. So now let me take a pen for this problem. For now, first let's start with the Q0 state. When Q0 will get a value of A, then it gives us it goes to state Q0 itself, and we get output 0 at Q0 state. Then we can write here A 0, and from Q0 state, if we give input of B, we get output of 1. So we can write 1 here. Now we should come to Q1 state. From Q1 state, if we give input of B, we get 1. So we can write B slash 1 here. From Q1 state, if we give input of A, we get an output of 0. So we can write this here. And we can remove these from here. We got our final Mealy machine. You can check this on the next slide. You can check your answer on the next slide also. So this is how it actually will look like at last. You can check the answer, you can see it. If you have any doubts, you can rewind the video and once again watch it. Now let's see one more example on Moore to Mealy conversion. So the next question for the Moore to Mealy conversion is given. So let's solve this question. In this question, we have given three states Q0, Q1, Q2, and the input strings are A and B. The output strings are 0 and 1. So let's start with Q0. When Q0 takes input string as B, it goes to Q0 state itself, and the output given is 0. So let's write here 0. Now when Q0 takes string A, it goes to state Q1, and the output is 0 here. Now let us see for the Q1 state. Q1 state when takes input string as A, the output is 0. The Q1 state when given the input string as B, the output given to it as is 1, and it comes at Q2 state. Now Q2 state when takes A as input string gives us 0 as the output. When Q2 takes B as input string, it gives us 0 as output. Now we can remove all the outputs from the given states. This is the final answer for the question. I have given the solution in the next slide very clearly. You can check that also. This is how the solution of our previous question would look like. You can take screenshot of the solution if you want to, or you can rewind the video if you have not understood any point. Now we will move to the Mealy to Moore conversion. Mealy to Moore machine conversion can be a little bit tricky as compared to Moore to Mealy conversion. So we have divided this process in given three steps. Let us understand the stepwise. For each state Qi, calculate the number of different outputs that are available in the transition table of the Mealy machine. Step 2. Copy state Qi. If all the outputs of Qi are the same, break Qi into n states as Qn. If it has n distinct outputs where n can be equals to 0, 1, 2, etc. Step 3. If the output of the initial state is 0, insert a new initial state at the starting which gives one output. We will discuss these steps with the help of an example. So given is an example of Mealy machine, and we have to convert this Mealy machine into Moore machine. So given are Q1, Q2, Q4, Q3 states, and the input string values are A and B, and the output string values are 0 and 1. So let's first see the solution of this question. This is the solution for the given problem. Now the question is, how can we reach this solution? So let's start with the Q1 state. The Q1 state, when it takes A as an input string, it gives us 1 as the output. So when A is the input string, 1 is the output. We can write it here. When Q1 is given B string as input, the 0 is output and it goes to Q2 state. So V goes to Q2 and we write output as 0. Now we will see on the next states why we have written Q2 node here. When now Q2 takes A as input string, it gives us 1 as output and goes to Q4, and also same for the B input string. Now Q4 when takes A, Q4 when takes A gives us 0 as the output string and goes to Q3 state. And we have also written Q3 node here also. So let's see. Now when we take B as input string for Q3, the output is 1. But we have earlier written here that the output for Q3 state is 0. But here the output for Q3 state is also 1. So to specify these output that a state can have multiple outputs in this problem, so we can write like this Q3 node and Q3 1. Similarly, when this takes B as input string, it comes to this and 1 is the output. Now when Q3 takes A as input, it goes to Q2 state and gives an output of 1. But earlier the Q2 had the output as 0, now it has 1, so we have made another state for Q2. So that is in a Moore to Mealy conversion, there must be the same number of states when we convert the machines, but in this case we can have more number of states in the converted solution. Thank you everyone. That was all for today's video. I hope you all like it. I have made this video for my assignment of the course Automata, Theory and Computability in my university exams. Hope you like it. Thank you.